In our introduction to statistics during Algebra 2, we've now come upon the normal distribution and trying to introduce how the normal distribution is used with coming up with data information. So when we look at this graph is a graphical representation of the normal distribution. A lot of data falls within this distribution, where if you look at a distribution, it will have this kind of shape where a lot of the data points will fall in the middle, and then they'll have on both sides a kind of symmetrical tails on both ends. So with the normal distribution, we usually center the graph on the mean, which is the average. And this is the center of the graph. And then we usually measure the spread of the graph, or how wide it is, using what's called the standard deviation. Now, actually calculating the standard deviation is outside the scope of what we're doing here. We're going to rely on the calculator. We're given information to give us the standard deviation. So when we look at a graph like this, the representation of it, what you have to recognize is that the mean is right in the middle. So the mean is right here in the middle of the graph. And then what we have is that this line here represents one standard deviation above the mean. So here's the mean, and this line is one standard deviation above the mean. 34% of the data typically, approximately, will fall in this data range. And this value over here, this line here, represents one standard deviation below the mean. Notice if you look at the amount of data between the mean and one standard deviation below, we also have 34%. So what we're going to look at is what is it when we accumulate these regions of how many standard deviations above or below the mean we are. First of all, we've got to acknowledge that if we have the mean here, if it's a normal distribution, 50% of the data is below the mean, and 50% of the data is above the mean. So we have half on each side. Now, if we take these two, if we go approximately one standard deviation above the mean and one standard deviation below the mean, if you take this 34% and 34%, we have approximately 68% of the data will fall between the one standard deviation above and one standard deviation below. If we go all the way out here to two standard deviations above and two standard deviations below, if we add up all of these numbers, what we get is about 95% of the data will fall between two standard deviations above and two standard deviations below. So it's 95%. And then that's a lot of the data. That's most of it. But if we go even further, let's say we go out to 3 standard deviations above and 3 standard deviations below. So if we look at this one, so this will be 3 standard deviations above and 3 standard deviations below. That data set, if you add up all of these numbers, we get approximately 99.7%. That is almost all of the data will fall within 3 standard deviations above and 3 standard deviations below. So what we're going to do now, in looking at this data, we're going to go ahead and talk about some specific problems. let's fill in this information. So if we have a mean at 78, that would put it right in the middle here, 78, and then a standard deviation of 10. That means when I go up to the next point, that's going to be 88. The next two standard deviations above would be 98. If I go one standard deviation below, that's going to be at 68. And two standard deviations below will be 58. Okay, so notice if I have those values for my standard population here, what percentage of scores fall between 68 and 88? Now what we can do is that's one standard deviation above and one standard deviation below. And I should add that this is what's called the empirical rule. These values approximate how much data is going to fall. So if we look at one standard deviation above the mean and one standard deviation below the mean, 68% of the data should fall in this region. So really, if you look at this up here, it's kind of like adding that 34 plus 34 and you get 68% if you're looking at the different regions on this one. Now it says what percentage will score below a 78. So if 78 is right here in the middle, we want to know what percentage will fall over here on this side. Well, if you think about it, that's below the mean. So 50% of the data should fall below that. And then lastly, what percentage of scores will fall below 58? Notice that we've got here, this is 68 and then 58 is here. That's two standard deviations below the mean. So remember up here when we look at these regions, we've got 34 and 13.5. So this region here is 34%. This area here is going to be the 13.5%. So 13.5. So those two regions, I'm going to take the whole thing from the middle and subtract those two off. So I'm going to take 50% minus the 34 in this next region, minus the 13.5, that's what this number is. I'll write that a little bigger up here, 13.5, and that will give us what's left over out here. So if you take those and subtract, what you get is about 2.5% of the data will fall out past two standard deviations below. Now you might wonder, why is that not the 2.35? Well, remember this 2.35 ends at 3 standard deviations below, and we've got a little bit of a tail, a little bit of area down here below that, that goes further. All right, now that's for a specific data set. What we often do with our data sets is we will oftentimes standardize it, where instead of using a specific number for the mean and standard deviation, we'll call the mean at 0, the middle of the graph is 0, and then this would be how many standard deviations we're going above and below the graph. So if we say mean equals 0, standard deviation is equal to 1, and this -1 is 1 standard deviation below, -2 is 2 standard deviations below. We now can use this information. Let's go ahead and fill those percentages back in here. Remember there was a 34% here in this region, and then a 34% in this region, and there's a 13.5% here in this region, and in this region a 13.5%. These are just mirroring what we have up on this graph up here with these percentages. And then between 2 and 3, we have 2.35%. And out here we have 2.35%. And then there's little tails a little bit past 3 and -3. Now, what if we want to find the percentage that lies between -1 here and +2? What would that percentage of data fall between those? Well, what we're going to do is we're going to take the different regions, like here's a 34%, here's another 34%, I'm going to add those two, and then we have a 13.5. So we're just going to add those regions, 34 plus 34 plus 13.5 will give me that when you add those up, you have about 81.5% of the data falls between 1 standard deviation below the mean and 2 standard deviations above the mean. Let's do lie between 1 and 3. So here we would have a 1, and then up here we would have, here's 2, and then here's 3. So for these values here, we have 13.5 here, and we have this last one is 2.35 down in this region. So if we want to find between 1 and 3, we're just going to add those together. 13.5 plus 2.35, and so what you get is 15.85%. How much lies between 1 standard deviation above the mean and 3 standard deviations above the mean. All right, now let's take a look at our last idea, which is called z-scores. Z-scores, what they do is they tell us how many standard deviations are we away from the mean. So how many standard deviations away from the mean? So we're going to use the standard normal distribution for this. And so we'll use the data value, let's say we're dealing with heights. This might be a specific person's height. You subtract the mean of the heights and put it over the standard deviation of heights. This is a hyphen, that's subtraction. Z-score is what we call this value that we'll come up with. So find the z-score. If the mean is 18, standard deviation is 3, and the score is 16. So the z-score will equal the score itself, the data point, minus the mean, which says mean is 18, and divide by the standard deviation of 3. So you get -2/3. Basically that means you've got your 2/3 of a standard deviation below the mean because it's negative. 2/3 of a standard deviation below the mean because of the negative. All right, so let's now try the next one. If we were to enter this on a calculator to find our data information, so take this list of numbers. The minimum is 198, the maximum is 219. Enter it into a calculator and get out the information from that. What you would find is that the mean of this data set is, I'm going to use X bar for it, is 207.4. And that the standard deviation is equal to 6.6 from that. So now we got that from the calculator, the mean and standard deviation. We can now find the z-score that's associated with this data point, 212. So the z-score will equal 212 minus 207.4 divided by 6.6. And when you do that calculation, you should get it rounded to about 0.7. So this says we're above the mean because it's positive. We're about 7/10 of a standard deviation above the mean with 212. Now, if we were to take our list of numbers and add the number 250 to it, if we were to just put this and add 250 onto it down here, how would that change our data, our statistics that are produced by this? Well, if you put that in and on your calculator, find the mean with this new value added on, the 250, is now going to be 210.7, which notice it raised that mean. So it raises the mean because it's a larger value. It's not close to the mean, so it's going to raise up the mean. And then the standard deviation is quite radically changed. It moves to 13.4. Notice it over doubles the standard deviation. Now the question is, explain that. Well, what's happening is this is such an extreme value. 250 is extreme. It's really pulling the data not only over, pulls the mean over to the right toward that extreme value, but it really shows that the spread of the data now has increased quite a bit because this extreme value has been added to the data set. So we've looked at normal distributions and we focused on the mean at the center and then using the standard deviations as markers of data away from it, either above or below. And then we've talked about how much data is between it percentage-wise, and then we've extended it all the way to do this calculation. We now can find what's called a z-score, which will help us in analyzing this data.